put 1.6. Instead of 3000, put 1. Instead of 2000, put 1.66. So calculation will be easier. So per unit, we'll see later what are the merits or what are the advantages of per unit method. Number one advantages, we can put whole the power system network in a single base, KVA voltage and power. We can convert each one, and also the voltage can be also here. Our base voltage is 11 kV. That means per unit voltage. Here per unit power, and now see the per unit voltage. The power part is over. Now take the per unit voltage. Per unit voltage means once again actual voltage by base voltage. Per unit voltage of transformer in low voltage side. How much? It is actual voltage 11 kV and base voltage once again 11 kV. So it is equal to 1 per unit. So instead of 11 kV, we will put 1 per unit voltage. Now, in the ST side, high voltage side, what will happen? It will be 66 kV, but base voltage is 11 kV. So it will be 6 per unit. So instead of 66, here we will put 6 per unit. Here we will put 6 per unit voltage. Here we will set 1 per unit voltage. So 11 will convert to 1, 66 will convert to 6. Once again, instead of 66, at the time of calculation, we will put 6. The calculation will be more easier. So this is the one advantage of per unit system. And then after that we will see the per unit. And one thing, if here the reactance of LT side, if it is X ohm is reactance, do you think it will be same in case of ST side? Never. The reactance will be different. But we will see in the next class the per unit reactance of LT side and per unit reactance of ST side, both will be the same. And if it is, then we can convert this transformer with its whole the transformer with its a single reactance. This as the per unit reactance of the transformer in HT side and per unit reactance of the transformer in LT side will be the same. Then we can convert this transformer with another reactance. And this is the transmission line. Transmission line can be converted with another reactance. And the load, it is converted with another reactance. If we omit the resistance, then what we'll get? We'll get one single circuit. We'll get one single loop circuit. That it was our desired. Suppose that this is X1, this is X2, this is X3, this is X4. Then it's X equivalent. X equivalent will be summation of all these. That means X1 plus X2 plus X3 plus X4 plus like that. And once its voltage is known, and all these are the per unit. Suppose that it is 10 point, right? It is 10.45 per unit X equivalent, and its voltage is how much? Its voltage is 1 per unit. Then what will be the fault current? I fault in per unit, obviously it is equal to 1 per unit voltage V per unit by X equivalent per unit. That means 1 per unit voltage by X equivalent. Then we will get the I value of I per fault in per unit. We will get, and from per unit value, how the actual value, per unit value is not the actual value. So by equating these per unit value, we will convert it in actual value. You can ask me how. It's very easy. From the very basic definition, per unit, I per unit means how much? I actual by I base. I base. Now, I per unit fault current is known. So here put that I per unit put here. So it will be I fault per unit. I base, it is not derived from V base, KVA base and KV base, or power base, voltage base. I base is also known. So I actual will be I actual current in amps will be I fault per unit into I base. I base is also already derived. So I per unit, I fault per unit, which is converted through these and multiplied by I base, and we will get I actual in amps, and it is our desire. So I think how using the per unit system we will convert it in all the power system network in a single loop network, and from that per unit network, so fault will be fault current will be I fault is equal to V per unit and X equivalent per unit, and from that I fault will be find out in per unit. That per unit value will be converted in actual value, and we will be able to find out the fault current. Once the fault current is known and the fault at the time fault point, the voltage will be known, and the fault voltage and fault current, from that we will get the fault power. Okay, so today up to this, and in the next class we will see furthermore application of per unit method. Okay, and then this per unit method will be further clarify about the various Z to find out the various method of per unit method of Z, find out from the percentage reactance, actual value of reactance, and per unit reactance. Z can be value can be given in problem in three types. One is Z per unit, Z percentage reactance, and or Z in ohm. So how that three types of Z can be handled, we will see in the next class. Okay.